Imagine a medieval potter crouching before a mound of glowing earth, peering through a small opening in the kiln wall. Inside, the air shimmers at nearly 900 degrees. The vessels he loaded 2 days ago are undergoing an invisible transformation. Soft, fragile clay is fusing into hard ceramic that will last for centuries. One wrong decision now, one gust of wind shifting the flames the wrong way, and the entire batch could crack, warp, or collapse into a pile of worthless shards. This is the moment that separates a master potter from an apprentice. This is the moment where weeks of labor either become useful goods or broken waste. And this craft, practiced in workshops scattered across medieval Europe from the 9th century onward, shaped the everyday life of an entire civilization. Long before a vessel ever reached the kiln, the process began in the earth itself. Medieval potters searched for clay deposits near rivers, lakes, and marshlands, where centuries of water flow had deposited fine-grained sediment in thick, workable layers. A good clay source was a prized asset, sometimes fought over, sometimes protected by local lords who taxed its extraction. The potter or his apprentices would dig into these deposits with wooden spades and iron-tipped tools, pulling out heavy wet lumps of raw material still filled with stones, roots, insects, and organic debris. This was not the clean, refined substance we imagine. It was rough, dirty earth that smelled of the riverbank and crumbled unpredictably in the hand. The raw clay had to be cleaned before it could ever be shaped. Medieval potters used a process called levigation. They would break the clay into small pieces, submerge it in water-filled basins or settling ponds, and stir the mixture until the finest particles separated from the heavier impurities. Stones and gravel sank to the bottom. Roots and organic matter floated to the top and were skimmed away. What remained was a liquid slurry of pure, fine clay suspended in water. This slurry was then poured into shallow drying beds or cloth bags and left to slowly lose its excess moisture until it reached a thick, workable consistency. In northern Europe, where rain was frequent and drying took longer, potters sometimes spread the clay on wooden boards inside their workshops and waited days, even weeks, for it to reach the right state. The Anglo-Saxons likely used small settling ponds or barrels for this very purpose, turning raw earth into refined material through patience alone. But clean clay was not yet ready for the potter's hands. Pure clay on its own is dangerously unpredictable. It shrinks unevenly as it dries, cracks under stress, and can explode in the kiln when trapped moisture turns to steam. Medieval potters understood this problem intimately, and their solution was tempering, mixing the clay with coarser materials to control its behavior. Sand was the most common temper in many regions, added to the clay and kneaded in by hand until it was evenly distributed throughout the body. Some potters used crushed shell, ground up fragments of old broken pottery called grog, or even choit straw and dried grass. Each temper changed the character of the clay. Sand made it more resistant to thermal shock in the kiln. Grog reduced shrinkage. Organic matter burned away during firing, leaving tiny air channels that made the finished vessel lighter and more porous. The choice of temper was a regional tradition, passed from master to apprentice over generations, and archaeologists today can often identify where a pot was made simply by analyzing what was mixed into its clay. Once tempered, the clay underwent its final preparation, kneading. The potter would take a lump and work it vigorously on a flat stone or wooden surface, pressing, folding, and turning it repeatedly to remove air bubbles and create a smooth, uniform consistency. Air trapped inside the clay was a death sentence for a pot. In the heat of the kiln, that trapped air would expand violently and shatter the vessel. A skilled potter could feel the difference between properly kneaded clay and clay that still harbored hidden pockets of air. This tactile knowledge, impossible to write down or teach from a book, was one of the most important skills a medieval craftsman possessed. Now came the shaping. In the early medieval period, most pottery across Europe was built by hand, using one of the oldest techniques known to humanity, coiling. The potter rolled out long ropes of clay between his palms and the work surface, each coil roughly the thickness of a thumb. He then stacked these coils one upon another in a spiral, pressing each new layer firmly onto the one below, gradually building up the walls of the vessel. As the walls rose, the potter smoothed the inner and outer surfaces with wet fingers, a piece of leather, or a flat wooden tool, blending the coils together until the joints became invisible. A skilled coil builder could create vessels of surprising symmetry and elegance, but the process was slow. A single large storage jar might take an entire day to build, and it had to be left to stiffen between stages so the soft walls would not collapse under the weight of new coils added above. The potter's wheel changed everything. By the high medieval period, wheel-thrown pottery had become the dominant method in most of Western Europe. The medieval wheel was a remarkable piece of engineering, largely constructed of wood, with a heavy flywheel at the bottom and a flat throwing head at the top, both mounted on a single vertical axle that was fixed into the workshop floor. Two main types existed. The cartwheel type resembled a large horizontal wheel that the potter spun by hand or with a stick, sitting above or beside it, while shaping the clay on the spinning head above. The kick wheel allowed the potter to power the rotation with repeated pushes of the foot against the lower flywheel, freeing both hands to work the clay continuously. Archaeological excavations in Reiren, Belgium, revealed the foundations of late medieval potters' wheels, with steel axles set into the workshop floor, proving that some potters invested in metal components to improve the speed and stability of their wheels. These steel axles reduced vibration and allowed the heavy wooden flywheels to spin longer and more smoothly, a direct advantage when throwing larger, more complex vessels. On the wheel, a potter could produce in minutes what took hours by hand. He slapped a prepared lump of clay onto the wet wheel head, centered it with firm, steady hands as the wheel spun, then opened a hole in the center and slowly drew the walls upward, thinning and shaping them with practiced pressure from inside and outside simultaneously. The spinning motion created perfectly round, symmetrical forms. Jugs, bowls, cooking pots, pitchers, and cups emerged from the clay in fluid, continuous movements. The potter's hands, slick with water, guided the spinning walls with an intuition built from years of practice. Once the basic form was complete, the potter used wooden ribs, wire tools, and damp cloths to refine the shape, trim excess clay from the base, and add details like rims, spouts, and handles. Handles were typically pulled. A lump of clay was held in one hand, while the other pulled it downward repeatedly, stretching and smoothing it into a long curved strap that was then attached to the vessel body with slip, a liquid mixture of clay and water that acted as a glue. The freshly formed vessels could not go straight into the kiln. They needed to dry slowly and evenly, a process that could take anywhere from several days to 2 weeks depending on the weather, the thickness of the walls, and the humidity of the workshop. Pots dried too quickly would crack as the outer surface shrank faster than the interior. Medieval potters arranged their wares on wooden shelves or boards inside the workshop, sometimes turning them periodically to ensure even drying, and carefully controlling airflow by opening or closing shutters and doors. Only when a pot had reached the leather-hard stage, firm enough to hold its shape, but still containing some residual moisture, would the potter consider it ready for the next step. And now we arrive at the heart of this craft, the kiln itself. Medieval pottery kilns were specialized structures, purpose-built for the single task of transforming clay into ceramic through sustained, controlled heat. The most common type across medieval Europe was the updraft kiln. In this design, the firebox sat at the base. a chamber where wood was burned to generate intense heat. Above the firebox, separated by a perforated floor made of clay bars or a pierced clay platform, sat the firing chamber where the pottery was stacked. Heat and flames rose from the firebox below, passed through the perforations in the floor, and moved upward through and around the stacked vessels, before escaping through a vent or chimney hole at the top of the domed roof. This upward flow of hot gases was the engine that drove the entire firing process. Building a kiln was itself a skilled trade. Many medieval kilns were dug partially into the ground, taking advantage of the earth's natural insulation to retain heat. The walls were constructed from clay blocks or bricks, often reinforced with stones. At Ipswich in England, archaeological evidence shows that Anglo-Saxon potters built single-flue updraft kilns set into the ground with ovens and stoke pits, using arches to form air vents in the walls. The dome of the kiln was often a temporary structure, rebuilt for each firing. Potters would weave a frame from hazel branches, pack wet clay over it, and leave a hole at the top for the chimney. When the kiln was fired, the hazel frame burned away inside, leaving the hardened clay dome standing on its own. This meant that every firing partially destroyed and rebuilt part of the kiln itself, a cycle of construction and destruction that was simply accepted as part of the craft. Loading the kiln was a meticulous, high-stakes operation. The dried vessels had to be arranged inside the firing chamber in a way that maximized the number of pots, while allowing heat to circulate evenly around each one. Pots were stacked rim to rim, nested inside each other, or separated by small clay supports called kiln furniture. If vessels were packed too tightly, the heat would not reach them evenly, and some would be underfired, soft, porous, and useless. If packed too loosely, the kiln was inefficient, and fuel was wasted. The potter had to understand how heat moved through his specific kiln, knowledge gained only through repeated experience, and inevitably through costly failures. Once loaded, the firing began. The stoker, sometimes the potter himself, sometimes a dedicated assistant, lit the fire in the firebox and began feeding it with wood. The initial phase was slow and deliberate. A gentle fire was maintained for hours, sometimes an entire day, to drive the last remaining moisture from the clay without causing thermal shock. This stage, called water smoking, was critical. If the temperature rose too quickly, trapped moisture would flash to steam, and the pots would crack or explode, sometimes violently enough to damage neighboring vessels and even parts of the kiln structure itself. Gradually, the stoker increased the intensity of the fire. More wood was added, the flames grew hotter, and the temperature inside the kiln climbed steadily, from 200 degrees to 400, then 600, then beyond. At around 573 degrees, a critical transformation occurred. The quartz particles in the clay underwent a sudden change in crystal structure, expanding slightly. This was another dangerous moment. If the temperature rose unevenly, different parts of the same pot could expand at different rates, creating internal stresses that led to cracking. Only a steady, controlled climb through this temperature range could avoid disaster. As the kiln reached 700 to 900 degrees, the clay began to sinter. The fine particles started to fuse together at their contact points, bonding into a single solid mass. The pots were visibly changing now. Through peepholes in the kiln wall, the potter could see them glowing a dull red, then a brighter cherry red as temperatures climbed further. The atmosphere inside the kiln, whether rich in oxygen or choked with smoke, affected the final color of the pottery. An oxygen-rich firing produced red and orange tones as iron in the clay oxidized. A smoky, oxygen-poor firing turned the same clay gray or black through reduction. Medieval potters manipulated the kiln atmosphere deliberately, controlling the airflow through vents and stoking holes to achieve the colors their customers demanded. The peak temperature was held for hours, sometimes through an entire night, as the stoker maintained a constant feed of fuel. This was exhausting, physically demanding work, tending a roaring fire in oppressive heat, hauling and splitting wood, monitoring the kiln through small openings while waves of heat blasted outward. The stoker watched for visual cues: the color of the glow inside the kiln, the behavior of the flames at the vent, sometimes the melting of small clay test pieces placed inside specifically for this purpose. There were no thermometers. There were no gauges. Everything depended on experience, instinct, and the hard-won knowledge of how this particular kiln behaved under these particular conditions. After the peak firing was complete, the kiln was sealed and left to cool. This phase was almost as critical as the firing itself. If the kiln cooled too quickly, thermal shock would crack the newly fired vessels. The potter blocked the stoking hole and sealed the vents with clay, trapping the residual heat inside and forcing the temperature to drop gradually over 1 to 3 days. Only when the kiln had cooled to a temperature safe to touch would the potter break open the dome or door and begin unloading. This was the moment of truth. Each vessel was examined carefully. Cracks, warping, discoloration, underfiring, overfiring. Any defect rendered a pot a waster, fit only to be crushed and recycled as grog for the next batch of clay. Even in skilled hands, losses of 10 to 20% were common. Archaeological excavations of medieval kiln sites often reveal massive dumps of broken wasters, silent testimony to the thousands of pots that failed to survive the fire. The vessels that survived were already functional, but many received an additional treatment: glazing. Medieval potters across Europe used lead-based glazes to create a smooth, waterproof, and often colorful surface on their wares. The basic glaze recipe was remarkably simple. Lead oxide, usually in the form of galena or ground to a fine powder, was mixed with water, and sometimes with a small amount of clay or flour as a binder. This mixture was applied to the surface of the pot, either by painting, dipping, or dusting the dry powder directly onto the vessel. When the glazed pot was fired a second time, at temperatures between 700 and 900 degrees, the lead oxide melted and fused with the silica in the clay body, forming a thin, glassy coating that sealed the surface. The addition of metallic oxides created different colors. Copper produced greens, iron gave yellows and browns, manganese yielded purples and blacks. These decorated glazed vessels were prestige items, tableware for merchants, clergy and nobility, far more expensive than the plain, unglazed cooking pots used by common households. The dangers of lead glazing were not understood in the medieval period. Potters who ground lead ore and handled lead-based mixtures day after day absorbed the toxic metal through their skin and lungs. Lead poisoning was an invisible, chronic hazard of the trade, causing fatigue, abdominal pain, tremors, and eventually organ damage. The consumers who ate and drank from lead-glazed vessels also ingested small quantities of lead that leached into acidic foods and beverages. This slow poisoning, affecting both producers and users, was one of the hidden costs of medieval ceramic technology that would not be fully recognized for centuries. By the 13th and 14th centuries, pottery production in many parts of Europe had become a specialized, organized industry. Potters' guilds regulated who could practice the craft, set quality standards, controlled prices, and managed the training of apprentices. Major production centers emerged: Stamford and Ipswich in England, Siegburg and Raren in the Rhineland, Saintonge in France, each developing distinctive styles, forms, and glazing techniques that became their trademarks. These workshops operated on an almost industrial scale. Archaeological evidence from some sites reveals clusters of kilns operating simultaneously, with massive quantities of fuel being consumed and thousands of vessels being produced in organized firing campaigns. At some sites, the waste dumps from failed firings alone contain tens of thousands of pottery fragments, giving us a window into the sheer volume of production. The products of these kilns touched every aspect of medieval life. Cooking pots for the kitchen, storage jars for grain, oil and salted meat, jugs and pitchers for ale and wine, bowls for eating, lamps for light, roof tiles for buildings, floor tiles for churches and manor houses, chamber pots for the night, money boxes sealed shut until broken open, aquamaniles, elaborate water vessels shaped like lions, horses or knights, for washing hands at the dinner table. Ceramic was everywhere in the medieval world, an essential material second only to wood in its daily importance. And every single piece of it passed through fire in a kiln, built by human hands from the same earth that gave the clay. The medieval potter stood at the intersection of art, science, and brute physical labor. He understood the geology of his local clay, the chemistry of his glazes, the physics of heat transfer in his kiln, and the engineering of his wheel, though he would never have used any of those words. His knowledge was empirical, accumulated through generations of trial and error, passed down through apprenticeships that lasted 7 years or more, encoded not in books, but in the muscle memory of hands that had shaped 10,000 pots. When we hold a piece of medieval pottery today, a fragment pulled from the earth at an excavation site, still bearing the fingerprints of the potter who made it 700 years ago, we are holding the result of a complete technological system. From the riverbank where the clay was dug, through the settling ponds and the kneading bench, across the spinning wheel and into the roaring kiln, that small piece of fired earth carries within it the entire story of a craft that built the material foundations of medieval civilization.